Hey, calculates! So we got some crazy things going on today. We're going to start working with logs other than natural log. So on this first one where it says that y is now some other exponential base, we're really just going to show how we could, this is really just some fancy version of e to a power. So instead of having some constant to a power, we could say it really comes from having had e to some crazy power, that power being this. And so if we look at this to check to see how they might in fact be the same amount, if I were to take natural log of both sides, of course what happens on the right is that this is really 1, right? They cancel each other out. And when that happens, of course, the exponent all comes down. And same thing over here, after I natural log, the exponent comes down. And so on the left side, I have x natural log of a, and on the right side, I have natural log of a times x. Oh, so they are in fact the same thing. So really all it's saying is that yes, I now have a different exponential base, but it was a result of e to some power, which we've already been working with exponential base e. And of course, if I look up here and I think of a as 1, then I would have y equals 1 to the x, and 1 to any power, of course, is just 1. All right, so now I have this new log base, and notice it's probably something other than 10, although it could be 10, but if it is a 10, of course we won't write the 10 there. So we'll write things like log base 2 and log base 5. And so I'm curious as to how that is in fact equal to all of this stuff on the right. And so if I think about it, as I don't know, so I'm going to do a little proof over here. I don't know how much log base a of x is, so I'm just going to let it equal my favorite variable, y. I don't know why, because I said that, so that's why. And I get rid of the log. Of course, I would have to, one of the ways of getting rid of the log is to put it back in exponential form. So of course my exponential base would be a, right? And then that would be the exponent. And then x is the answer. And so I go, well, that's great, but I really like to get y by itself. So in order to get the power down out of the exponent, I would have to take log, and I'm saying, well, that's just going to take us in a big circle towards. Well, what if my version of log, my log base, preferred log base, is now natural log? Because I've become very comfortable working with natural logs. You know why? Because they're so natural. And of course, whatever I do to the left, I have to do to the right, which would allow me to bring down the y. And once I do that, I'll have y, oops, I didn't mean to write equals. So I'll have y natural log of a equals natural log of x. And if I want to get y by itself, oh yeah, I can just divide both sides by natural log of a. And that's really what this says over here, is natural log of x over natural log of a. Oh my gosh, look at all these proofs I'm doing. Is this geometry?